Hello, I'm Ed Murphy with the Astronomy Department at the University of Virginia, and this is Astronomy 1210, Introduction to the Sky and Solar System, Lecture 13, Solar and Lunar Eclipses. 2 lectures ago, we looked at what causes the phases of our moon. And when I was outside building a physical model of the phases of the moon, you probably experienced both solar and lunar eclipses. So in this lecture, we will examine what solar and lunar eclipses are and what conditions have to be in place for them to happen. In the next lecture, we'll actually talk about taking a trip to see a total solar eclipse and talk specifically about what you'll see during an eclipse. And then the lecture after that, we'll talk in more detail about the conditions that are required for a total eclipse. Now, before I go any further in this lecture, I really want to say this lecture should have a separate title, which is, Where Will I Be on April the 8th, 2024? If you don't know what April the 8th, 2024 will be known for, you'll find out in this lecture. I'll give you a hint right now. It is the next total solar eclipse in the continental United States. Behind the text here, you can see a picture of the United States, and that yellow path cutting from the lower left to the upper right is the path of totality, the path of the shadow of the moon on April the 8th, 2024. You need to plan to be somewhere inside that yellow band on April the 8th, Monday, April the 8th, 2024. And we'll talk more about that both in this lecture and the next one. But to understand eclipses, the first thing we have to understand is how a body in space casts a shadow. So the shadow of a body consists of 2 parts. Imagine that we have a body sitting here in space. It can be the moon, it can be the earth, and the sun is off in the distance right there, and that body is casting a shadow off into space. There are 2 parts to the shadow. There is the umbra right here. It's shaped like an ice cream cone, and then there is the much wider, much larger penumbra. The umbra is where the sun is completely blocked from view. And the penumbra is where the sun is only partially blocked from view. So let's take a little bit closer of a look at this. Let's imagine that this is the moon for an instant. We'll just call this the moon. And imagine that we have 4 observers, and they are at positions A, B, C, and D. What do they see at each one of these different positions? Well, if you are at position A, you are inside the umbra of the moon. You are inside the darkest part of its shadow, where the moon completely covers the sun from view. You are close enough to the moon that the moon is large enough that the sun is completely covered. At B, you find yourself a little bit off to one side of the moon. If we're looking down on top of the moon from over here, you're a little bit off to the right of the moon. And when you're standing at B and you look at the moon, over to the right-hand side of the moon, you can glance just past the moon and catch the edge of the sun. So someone standing at B right here is in the penumbra of the moon. That is a partial eclipse, and this is what they see. The moon is only partially covering the sun. Now, if the moon was moving in this direction, a person at B might in a little while find themselves inside the umbra, but at this moment in time, they're experiencing a partial eclipse. Well, someone back here at C, they're far outside the center line of the eclipse right here. They're way over on the side, and when they look past the moon, they can actually see most of the sun. It turns out from position C, the moon is only blocking a little bit of the sun right there. So out at C, they are also in the penumbra, experiencing a partial eclipse, and the moon is hardly blocking any of the sun at all. And then at position D, we enter into a really interesting situation. They're on the center line of the eclipse. But in this case, they are far enough away from the moon that the moon is not big enough to cover the sun. And so there is an annulus, a ring of light around the moon. And we call this particular kind of eclipse an annular eclipse. So the first ones that we're going to talk about are total solar eclipses. A total solar eclipse is when you find yourself inside the umbra of the moon. They are, of all the eclipses, by far, hands down, the most spectacular eclipses. And so let's start with total solar eclipses. So here's what happens during a total solar eclipse. During a total solar eclipse, the moon is casting its shadow down onto the surface of the earth. The moon is far away from us that the shadow just barely makes it to the surface of the earth right there. If you find yourself inside the umbra, you experience a total solar eclipse. If you find yourself inside the penumbra, you experience a partial eclipse. Now, It's a little bit tricky on the Earth because the moon is orbiting around the Earth. So this shadow is not sitting still. As the moon orbits the Earth, its shadow sweeps across the surface of the Earth. And as you saw a minute ago in that eclipse path for 2024, people who happen to live along this line experience the total solar eclipse. People outside that line, on either side of it, experience a partial eclipse, and people outside that don't experience any eclipse at all. So before we go on talking about total solar eclipses, I want you to go to Learning Catalytics and answer this question. During a total solar eclipse, what is the phase of the Earth as seen from the moon? So that is, think about this. During a total solar eclipse, what is the phase of the moon and what is the phase of the Earth as seen from the moon? So go ahead and take a few seconds, go over to Learning Catalytics and answer this question. Okay, welcome back. What did you get for the answer to this one? I hope what you got here is realizing that in order for the shadow of the moon to be cast down on the Earth, the moon must be between the Earth and the sun. In fact, it has to be directly between the Earth and the sun. So a total solar eclipse only occurs when the moon is new. And if you're standing on the moon looking back at the Earth, you see a full Earth. So the answer to this one is, what is the phase of the Earth as seen from the moon? And the answer is C, it's a full Earth. Now let's talk specifically about the conditions during a total solar eclipse. Under the most favorable conditions, the best possible conditions, the diameter of that icicle cone, that ice cream cone, that shadow cone, the maximum diameter on the surface of the Earth is just 269 kilometers. That's 167 miles across. So the biggest this spot can be is 167 miles in diameter. And it's not sitting still. At the equator, the shadow is moving 1,730 miles an hour. At higher latitudes, it's moving even faster. In fact, one of the reasons that it's moving this slow is because the rotation of the Earth helps us out. The moon is orbiting the Earth, so the moon's shadow is going very quickly this way. Fortunately, the Earth is also rotating from west to east, and that Earth's motion helps keep you inside the shadow a little bit longer. But the shadow is moving as slowly as 1,700 kilometers an hour. That's over 1,000 miles an hour. Well, you can do a little bit of math there. It's moving at over 1,000 miles an hour. The shadow cone itself is only 167 miles in diameter. And that means that on Earth, totality, the longest that a total solar eclipse can last is 7.5 minutes. But I have to say, eclipses over 7 minutes are really rare. And for the rest of your lifetimes, there will be no eclipse that is over 7 minutes long. These really long solar eclipses are quite rare. But when we talk about a total solar eclipse, we are talking about an event that lasts typically 2, 3, 4, if you're really lucky and seeing a really good eclipse, 5 or 6 minutes, and for a really, really rare, very, very rare, outstanding eclipse, 7 minutes or more. So let's put this in perspective. I hope some of you got to see the total solar eclipse on August the 21st, 2017. I was fortunate enough to be at a camp in South Carolina where we had spectacular conditions and a beautiful clear day and saw the eclipse from beginning to end. On that day, the diameter of the shadow on the surface of the Earth was 114 kilometers across. That's about 71 miles. And the speed of the shadow was 2,330 kilometers per hour. That's 1,450 miles per hour. So the maximum duration was only 2 minutes and 40 seconds. And here's the path of that eclipse in August of 2017, cut all the way from the west coast of the United States to the east coast of the United States. It did that in a bit more than an hour. And as I saw it said in that last slide, this shadow cone here, that spot at its largest was only about 71 miles across from side to side. So if you wanted to see that eclipse, you had to travel to get inside that shadow cone. I think that seeing a total solar eclipse has to be on your bucket list. Now, I know most of you are very, very young and you probably haven't even thought of a bucket list. You may not even know what it is. So a bucket list is a list of things that you want to do before you kick the bucket, before you die. And a total solar eclipse absolutely has to be on your bucket list. I've been fortunate enough to see 3 total solar eclipses. They are 3 of the most spectacular things I have ever seen in my life. All of them were memorable. And even though I've seen 3 of them, I cannot wait to go see my next one. They really are spectacles of nature. I like to compare it to looking at the Grand Canyon. The Grand Canyon should be on your bucket list as well. Everyone should see the Grand Canyon at some point in their life. But here's the thing. The Grand Canyon is visible 365 days a year, 24 hours a day. The Grand Canyon is always there. It's going to be there for the rest of your life. The problem with total solar eclipses is they only occur somewhere in the world about once every 18 months. And when they occur, they only last a few minutes long. So to see a total solar eclipse, you have to plan ahead. You can't wait for one to show up at your location. So a total solar eclipse occurs about once every 18 months somewhere in the world. If you decide that you don't want to travel and you want to wait for it to show up at your location, at any given location, a total solar eclipse occurs about once every 360 years. That's right, about once every 360 years. The next total solar eclipse in the United States is on Monday, April 8th, 2024. So that's the next total solar eclipse. And I know that sounds like a long way away, but here's the thing. People are already planning for that eclipse. Commercial companies are buying up hotel rooms. Tour companies are making plans. If you want to see this eclipse and you want to stay in a hotel, you need to be making plans now. You need to be thinking about buying your eclipse glasses. There was a tremendous shortage of solar eclipse glasses in 2017. So much so that those eclipse glasses, which normally sold for $1 a piece, weren't attainable in the 2 months before the total solar eclipse. And even before that, they were selling for well in excess of the $1 that you can normally buy them. You have to plan ahead to see an eclipse. So let's talk about your possibilities, the eclipses that you can see. Here are all the total solar eclipses from the year 2001 to 2020. I'll show you 2020 to 2040 here in a second. But just so you know, to give you an idea of the frequency of total solar eclipses, there are 2 kinds of eclipses shown here. The ones in blue are the total eclipses, and the ones in red are annular eclipses, and these sort of pinkish colored ones are hybrid eclipses, but they're really rare. You might be able to find one on this map. Don't worry about them. The thing is, annular eclipses, the moon doesn't completely cover the sun. They're interesting, but I would argue that they're not worth traveling very far to go see. However, the blue eclipses, the ones in blue, are the total eclipses, and they are absolutely worth going to see. So, for example, here is a red annular eclipse that actually just recently happened on June the 21st, 2020, streaking across the Earth. But you really want to see the blue ones. Those are the total eclipses. So you'll notice that between 2001 and 2020, there was a total of 1 total solar eclipse in the United States, and that was the one on August 21st, 2017. In fact, just to put it in perspective, before 2017, the last total solar eclipse in the continental United States was way back in 1979. How many of you were even born in 1979? The answer to that is, for my class, almost nobody. In fact, there's probably only 1 or 2 of us in the class that were born back in, remember, 1979. That's how long it was, 1979, and then the next one wasn't until 2017. So if you want to stay in the United States to see a total solar eclipse, you don't have many options. Here are all the total solar eclipses between 2021 and 2040. And you will notice that all the way until 2040, there is only 1 more total solar eclipse in the continental United States. And there it is, April the 8th, 2024. So between now and the year 2040, there is 1 total solar eclipse that you can see in the continental United States. To put that in perspective, here are all the total solar eclipses between 2001 and 2050 in the United States. And in that time, from 2001 to 2050 in the continental U.S., there was the eclipse on August the 21st, 2017. There is the eclipse on April the 8th, 2024, and an eclipse on August the 12th, 2045. There is also an eclipse in 2044, but it just cuts through North Dakota, Montana there, and it's not a very good eclipse. It's a really, really short total solar eclipse. So that's not a particularly good one. So here's the thing. if you miss the eclipse in 2024, if you say to yourself, oh, you know what, I'm young, I've got a long time, I'm going to see another one, you have to wait a full 21 years till the year 2045 before there will be another one in the continental United States. How old will you be in 2045? Do not miss the eclipse in 2024. Now, I know that many of you love Charlottesville. It's a wonderful place to live. You might decide after you graduate from the University of Virginia to stay in Charlottesville and live there. Lots of us have done that. And you might wonder, when is the next total solar eclipse in Charlottesville? The next total solar eclipse in Charlottesville, you actually don't have to wait that long. Go ahead and put this on your calendar. It's September the 14th in the year 2099. The next total solar eclipse in Charlottesville is September the 14th, 2099, right? So it's still from now more than almost 80 years away from right now. You might wonder, when was the last total solar eclipse in Charlottesville? Well, Charlottesville, interestingly enough, has had a dry spell, a drought of total solar eclipses. The last one in Charlottesville was on July the 29th, 1478. So let's put that in perspective. Charlottesville will wait from one total solar eclipse to the next total solar eclipse over 600 years between total solar eclipses. The average across the world is 360 years. Sometimes, though, you find places like Charlottesville where you can go 600 years between total solar eclipses. And then there are places like Southern Illinois, which had a total solar eclipse on August the 21st in 2017. And 6.5 years later, they're going to get another one on April the 8th, 2024. Imagine living in Southern Illinois and getting 2 total solar eclipses in 6.5 years. And in Charlottesville, we haven't had one in almost 600 years. So that is just sort of the vagaries of total solar eclipses. Okay, so I think the point that I'm trying to make here is, if you want to see a total solar eclipse, you have to plan to go see one. You can't just wait for one to show up on your doorstep. It's not going to happen. I love this quote from Rebecca Joslin in 1929. She said, "Now eclipses are elusive and provoking things, visiting the same locality only once in centuries. Consequently, it will not do to sit down quietly at home and wait for one to come, but a person must be up and doing and on the chase." You have to go see a total solar eclipse. Make your plans now. See the one in 2024. See the one in 2045. Hopefully you'll live long enough to see the one in 2099. Travel the world. See other eclipses as well. It is a fantastic hobby to travel the world to see total solar eclipses. In the next lecture, I'll get to show you some of my vacation pictures from the total eclipse trips that I've been on. All right, so what happens during a total solar eclipse? Why is it worth going to see? Again, in the next lecture, I will talk you sort of step by step what happens in a total solar eclipse. But very briefly, what happens is, as the moon is orbiting the Earth, it starts to pass in front of the sun. So initially, for about the first hour, little more than an hour, you are in the partial phases of the eclipse. And this is where the moon just starts to cover the sun. Little by little by little by little by little, the moon starts creeping in front of the sun. In these phases, because the surface of the sun is not completely covered, you need to wear eye protection. You need those sunglasses, not sunglasses, eclipse glasses. You need to buy a pair of specialty eclipse glasses to protect your eyes so that you can observe the sun. And then comes the moment you've been waiting for, and that's totality. Totality is when the moon totally covers the surface of the sun. Totality is the spectacular moment you've been waiting for. It is when it gets almost as dark as night outside. It's when you can see the corona, the beautiful outer atmosphere of the sun. You can never see the corona except during a total solar eclipse. All kinds of spectacular effects happen during a total solar eclipse, and it's only going to last for a few minutes. And after the moon will keep moving on in its orbit, and after just a couple minutes of completely covering the sun will start to recover, and the recovery will, like going in, take a little bit more than an hour. And again, you can watch with those eclipse glasses, you can watch these partial phases as the sun recovers. Okay, so these are the total solar eclipses on the Earth. Let's move to a learning catalytics question then. Thanks to the large size of our moon and its close distance to the Earth is the only body in the solar system which can have total solar eclipses. True or false? Are we the only body in the solar system that gets total solar eclipses? Okay, let's look at some of the other places in the solar system and see what they get. Turns out the answer to this one is false. The Earth is not the only place in the solar system. The Earth is not, let me phrase it clearly, the Earth is not the only place in the solar system that gets total solar eclipses. Other planets do as well. So Jupiter has 4 giant moons called the Galilean moons of Jupiter, and they cast their shadow back on the moon of Jupiter. Here is Jupiter's moon Io, seen by the Cassini spacecraft on its way out to Saturn. And as Cassini flew by Jupiter, it photographed Io in front of the planet Jupiter, and there was this little black spot on Jupiter, and that is the total solar eclipse that's going on Jupiter. Now, of course, Jupiter's a gas giant planet. It has no solid surface, and so you could not sit here on the surface and watch the solar eclipse. You could float in the clouds and see the total solar eclipse. All of the Galilean moons of Jupiter create shadows like this on Jupiter. You can see them even with a small backyard telescope. You can look up in almanacs when the eclipses will occur, and you can look at Jupiter and see these little black dots and watch them hour by hour as they slowly move across the face of Jupiter. It's a lot of fun to see these shadows on Jupiter. I absolutely love this photograph. This is a spectacular photograph taken in September of 2019 by the Juno spacecraft in orbit around Jupiter, and it was just skimming above Jupiter's cloud tops at this moment when it happened to catch the shadow of Io. Again, a total solar eclipse on Jupiter. Other planets in the solar system get total solar eclipses. In the case of Mars, the rovers sitting on the surface of Mars have photographed Phobos, which is the larger of Mars's 2 moons, passing in front of the sun. The problem is Phobos is not quite large enough to completely cover the sun. So this is an eclipse, an annular eclipse on August the 20th, 2013, as photographed by the Mars rover Curiosity sitting on the surface of Mars. So those are total solar eclipses. Now, we've already seen as the moon orbits the Earth in a slightly elliptical orbit. Sometimes the moon, once a month, the moon is closer to the Earth than average and looks a little bigger than average. And once a month, the moon is a little bit farther than average and looks a little bit smaller. If we have the moon being farthest from the Earth, and so it's smaller than average, at the same time that the Earth is closest to the sun, in January, so that when the sun looks a little bit larger than average, the moon can't completely cover the sun, and we get what's called an annular eclipse. So here's an example. You'll remember from my discussion of the supermoon in our last lecture that when the moon is at its closest, it looks bigger than when the moon is at its smallest. It's not significantly bigger. I certainly don't consider it to be a supermoon because it's super big, but it is definitely bigger than when the moon is at its farthest. So here is 2 diagrams that show the moon when it's at its closest to the Earth and therefore largest, and when it is at its farthest and therefore its smallest. Now the Earth is also in the sun, is also orbiting the sun on an ellipse, and so that means sometimes we are closer to the sun than average, and the sun looks bigger than average, and sometimes we are farther from the sun and the sun looks smaller than average. Sometimes when the moon is smallest and the sun appears biggest in the sky, the moon is not big enough to cover the sun, and what we end up with is an annular eclipse. An annular eclipse is what happens when that ice cream cone, the umbra of the moon, comes to a focus before it hits the surface of the Earth. So anyone that is behind that is on that center line on the Earth, they're going to miss a total eclipse because the moon is not quite big enough to cover the sun. But what they will get instead is an annular eclipse, or a ring of fire, as they're sometimes called, ring of fire eclipses. Annular eclipses are spectacular. I was lucky enough to go and see one back at the University of Illinois many, many years ago. They're really a lot of fun to go see, but here's the problem. Even though only 1% of the sun is shining around the rim of the moon, just 1% of the sun is shining, it is still not enough for all the special effects that you see during a total solar eclipse. The one that I saw, if I remember correctly, was in 1994. And we were on the campus of the University of Illinois at that day. We were actually showing people the sun, showing people the eclipse. But as you looked around you at maximum eclipse, even though only 1% of the sunlight was getting around the moon, it was still bright enough that you wouldn't really notice it. The terrain looked a little bit weird, but you probably, if you didn't know an eclipse was going on, not think twice about it. All the special effects that happen during total solar eclipses did not happen during the annular eclipse. So I think annular eclipses are worth going to see if you don't have to travel very far, but I don't think they're worth traveling the world to see. I do think that total eclipses are worth traveling anywhere in the world to go see. So let's take a look at some of these. These are upcoming eclipses in the world. So let's see here. Coming up in December of 2020, we have a total solar eclipse that will be visible in the Pacific Ocean, South America, and Antarctica. There's another total solar eclipse in December of 2021 that's visible only down in Antarctica. And then the next one after that is the total solar eclipse in 2024, which is visible right here in North America. You can also see that along the way there are some partial solar eclipses where the moon only partially covers the sun. It never is total or annular for anywhere on Earth. And then there are some annular eclipses as well. So those are solar eclipses. What about lunar eclipses? Lunar eclipses are what happens when the moon passes into the shadow of the Earth. So a lunar eclipse is when the moon, in its orbit around the Earth, passes into the shadow of the Earth. Basically what happens is the moon goes from being full to passing into the shadow of the Earth and almost disappearing. We'll talk here in a second about why it doesn't completely disappear, and then recovering and coming out the other side. Now, typically the moon does not completely disappear inside the Earth's shadow in a lunar eclipse because the Earth has an atmosphere, and our atmosphere can bend light. So even though the moon is inside the umbra of the Earth and no sunlight should be reaching it, some sunlight gets bent by the Earth's atmosphere. And that sunlight that gets bent is passing through the maximum amount of the Earth's atmosphere. And all the blue light gets filtered away and only the red light makes it through. Another way to think about it is, in fact, the light that's getting through is the combined light of all the world's sunrises and sunsets. And that light is deeply red in color. So very often during a total lunar eclipse, when the moon is completely inside the shadow of the Earth, it takes on a deep red color. And for that reason, sometimes the media in the past few years have taken to calling lunar eclipses blood moons. I'm not particularly a fan of that. I think it's a lunar eclipse. That's the proper name for it. We should call it a lunar eclipse. We don't need to sensationalize it. It is already a sensational spectacular up there in the sky. But as I said, sometimes the media have taken to calling them blood moons. So I like to stick to lunar eclipse. All right. So a lunar eclipse is visible to everyone on the night side of the Earth. And that's the great thing about lunar eclipses. Because the moon is passing into the shadow of the Earth and coming out the other side, everybody on the night side of the Earth gets to see the lunar eclipse happening as long as the weather is good in your area. You don't have to travel to see a lunar eclipse because half of the world gets to see it when they happen. And like total solar eclipses, on average, there's a total lunar eclipse about once every 18 months or so. Now, lunar eclipses like this are quite important in the history of humanity because, in fact, the great Greek philosopher Aristotle used lunar eclipses to demonstrate that the Earth was spherical. Just from this diagram, you can see the shadow of the Earth right there as the moon passes into the shadow of the Earth. And if you look at the shadow of the Earth, you will see that it's round. But more importantly, if you watch the eclipse from beginning to end as the moon passes into the shadow of the Earth and comes out again, you will not only see that the shadow of the Earth is round, but you will see that the Earth is bigger than the moon. Aristotle not only knew that the Earth was spherical, but he knew that the Earth was at least 3 times bigger than the moon. We'll see more about this later on when we talk about Greek astronomy. So here are the upcoming lunar eclipses. There are a number of different kinds of lunar eclipses. There are total lunar eclipses where the moon completely passes into the shadow of the Earth. There are partial lunar eclipses where the moon just skims the umbra of the Earth and it's partially blocked. And then there are penumbral lunar eclipses where the moon only goes through the penumbra of the Earth. It never gets into the umbra. The penumbral eclipses are not really worth looking for. Unless you're really lucky, you're not really going to see anything on the night of a penumbral eclipse. So, for example, we have 2 of them this summer. The next one coming up on July 5th, but and it's visible here in the Americas. You're welcome to go out and try and see it, but what you will see at best is a little very subtle shading on the side of the moon. Okay, the next total lunar eclipse is coming up in May of 2021. That will barely be visible here in the Americas, particularly on the east coast of the United States. This is what that lunar eclipse will look like. So here is the Earth's umbra. Here is the Earth's penumbra. The moon will actually pass into the Earth's umbra, get completely inside the umbra, and come out the other side right there. Here is the visibility plot of where it's visible. So the whole eclipse is visible in the Pacific Ocean and in the Southeast Pacific. Here in the continental United States, it's only partially visible. And here on the east coast of the United States, the total phases are not visible at all. You can see the eclipse is visible at moonset. Just as the moon is setting, the eclipse is just beginning and the moon is setting and disappears for us. So, in other words, to put it, is because the moon is full here, when the moon is setting, the sun is rising. So another way to say that is the eclipse is happening right at the moment of sunrise for us, and the moon sets while the sun rises. Okay. However, the total eclipse of May the 16th, 2022 is going to be visible in the Americas and will be well worth seeing. So those are total lunar eclipses. So those are total solar, annular solar, and total lunar eclipses. In the next lecture, we're going to talk about going to see a total solar eclipse. And I'm going to show you some vacation pictures from the 3 total solar eclipses that I've been on. They're a lot of fun. I'm going to show you some cool videos. So I will see you in the next lecture about traveling to see an eclipse.